This video goes through question 1 on the Leaving Certificate Chemistry exam 2024, and question 1, as always in Leaving Certificate Chemistry, is a titrations question. This particular titration is all about the concentration of ethanoic acid in vinegar, and ethanoic acid or vinegar is titrated against sodium hydroxide. It says a student carried out an experiment to determine the concentration of ethanoic acid in vinegar. A 10 centimetre cube portion of vinegar was first diluted to exactly 50 centimetres cubed. The diluted vinegar was titrated against a 0.09 molar sodium hydroxide solution in a conical flask. On average, 12.4 centimetres cubed of the diluted vinegar was required to neutralise 25 centimetre cubed of the sodium hydroxide solution. The titration reaction is described by the following balanced equation, in which we have ethanoic acid and sodium hydroxide going to sodium ethanoate and water. In part A, it says name the piece of apparatus used to measure exactly the 10 centimetre cube portion of the original vinegar. For that, the answer would be pipette. The second question says describe how this piece of apparatus was rinsed before use. Before you use the pipette, you should rinse it with deionized water, which I'm just going to write as DIW, and also with the vinegar solution. In part 3, it says describe a suitable method to dilute the 10 centimetre cube portion of the original vinegar to exactly 50 centimetres cubed. The first thing you would do is add the 10 centimetres cubed of vinegar to the volumetric flask. Using the pipette. Next, you make it up to the mark with deionized water. Again, I'm writing DIW, but you should write deionized water in the exam. And you want to make sure that the bottom of the meniscus is on the mark. In part BI, it says calculate the volume of the undiluted vinegar which will be required to neutralise the 25 centimetre cubed of the 0.09 molar NaOH. In terms of the amount that was the diluted vinegar, well, it says in the question that 12.4 centimetres cubed of the vinegar was used. There was a dilution factor of 5. The reason why we know there's a dilution factor of 5 is because 10 centimetres cubed was made to 50 centimetres cubed. It says that in the second line of the question, it says a 10 centimetre cube portion of the vinegar was first diluted to exactly 50 centimetre cubed. So 10 centimetre cubed to 50 centimetre cubed is a dilution factor of 5. Therefore, it would take 5 times less the amount if we were using the undiluted vinegar. So 12.4 divided by 5 will give us 2.48 centimetres cubed. Therefore, 2.48 centimetres cubed of the undiluted vinegar would be needed in this titration. However, we don't use undiluted vinegar because it gives us such a small value, increasing our percentage error and making it less accurate. That's exactly what the second part in B is asking us. It says outline an advantage of diluting the vinegar before carrying out the titration. When we dilute it, we have a smaller percentage error. And also, it would mean that we have a more accurate answer. C part I. It says, name a suitable indicator for this titration. When we're doing this titration, we use the phenolphthalein. And in part 2, it says, state the colour change observed at the end point. And we would see that it would have gone from pink to colourless. In part D is where we start looking at the titration calculations. In part I, it says calculate the number of moles in the sodium hydroxide in each 25 centimetre cube portion. It says here that we have a 0.09 molar sodium hydroxide solution. That means that we have 0.09 moles in 1,000 centimetres cubed. However, we didn't use 1,000 centimetres cubed of the sodium hydroxide in each titration. We used 25 centimetres cubed. So to figure out the amount of moles in the 25 centimetres cubed, I'm firstly going to figure out how many moles are in 1 centimetre cubed and then find out how many are in 25. So I'm going to divide by 1,000, and when I do that, I just add 3 zeros to my 0.9 moles to figure out how many moles are in the 1 centimetre cubed, and then to figure out how many moles are in the 25 centimetres cubed, I just multiply that by 25 and I get an answer of 0.00225 moles. 0.00225 moles of sodium hydroxide was added to the conical flask. Remember, this was done each time the titration was carried out. In the second part, it says, calculate the number of moles of ethanoic acid in each centimetre cubed of the diluted vinegar. Now we've gone from talking about the sodium hydroxide to the ethanoic acid. Looking at the chemical equation, we have ethanoic reacting with sodium hydroxide in a ratio of 1 to 1. So however many moles were in the conical flask, we would need the same number of moles of ethanoic acid reacting with it. We had 0.00225 moles of sodium hydroxide in the conical flask, meaning that we would have had to add 0.00225 moles of ethanoic acid for the entire reaction to take place and for us to see the colour change. That means that 0.00225 moles of CH3COOH was added to the conical flask. We also know from the question that on average 12.4 centimetres cubed of ethanoic acid was added. That means 12.4 centimetres cubed of the ethanoic acid had to have 0.00225 moles of the ethanoic acid, as the amount of ethanoic acid that's added in had to be 0.00225 moles as the reaction occurred when that amount of moles was added in. It wants to figure out how many are in 1 centimetre cubed. So to figure out how many are in 1 centimetre cube in terms of the number of moles, I divide by 12.4. When I divide by 12.4, I get an answer of 0.00018 moles. In part 3, it says calculate the concentration of ethanoic acid in the original vinegar in moles per litre. Now, in terms of the diluted vinegar, we can get its concentration in moles per litre. We have 1 centimetre cubed being 0.00018 moles. So if we multiply that by 1,000, that will tell us how many moles are in 1,000 centimetres cubed, which is a litre, and we would have 0.18 mole. That means that we have 0.18 moles per litre, or you can also write that as 0.18 molar, big capital M. That stands for the same thing. Now that's the diluted vinegar. We then need to look at the dilution factor to figure out the number of moles that are in the original vinegar. We've done that already. We saw that there was a dilution factor of 5. So we need to multiply this by 5 to get the concentration of the original vinegar. When we multiply 0.18 by 5, we get an answer of 0.91 molar. So in the original vinegar, we would have had 0.91 moles per litre. In the last part then, it says calculate the concentration in percentage W per V. And remember, that is grams in 100 centimetres cubed. At the moment, we have 0.91 moles per litre. So that's moles per 1,000 centimetres cubed. We need to change this into grams. So we have ethanoic acid, which is CH3COOH. Ethanoic acid, relative molecular mass, we have 12 plus 3 times 1, which is hydrogen, plus 12 plus 16 plus 16 plus 1, which gives us 60 grams per mole. So to figure out the grams, it's number of moles times the MR. So then the grams in this case, we will have the number of moles, which is 0.91 multiplied by 60. That means that we will have, in terms of grams, 54.6 grams per litre. Now, if we divide that by 10, we will get 5.46% weight per volume. And remember, we're dividing by 10 as we have 1,000 centimetres cubed in a litre. Dividing it by 10 will give us the amount in 100 centimetres cubed, which is what we want when we're getting percentage weight per volume. That brings us to the end of this question on the concentration of ethanoic acid in vinegar, which was the 2024 Leaving Certificate Chemistry question 1.